It's December 7th, 2024. I'm on the edge of Fraser Point at Santa Cruz Island, looking southward towards Kenton Point, Christie Ranch area, and then here's the channel that goes out towards Santa Rosa Island. And this is a good place to point out some of the major climatic changes here in the last 100,000 years or a little more. So today I'm at the edge of this sea cliff, and this is the modern sea cliff here, and then under the water here, because of the wave actions and currents, there's a bench being formed, like erosional flat surface that slopes oceanward, and we can't see most of that unless it's a very low tide. We'll get a little hint of it, but what's happened in the last 20,000 years, the sea level has advanced. As we've come out of the last big glacial period, sea level has advanced and made this modern sea cliff. So this is as far as it's got. And it's eroded into this deposit that makes up the upper half of this sea cliff. The upper half is pretty much younger, Pleistocene, Holocene deposits there. Below that, down here, is the Santa Cruz Island volcanics, is these dark layers. So this is the bedrock. This is 15, 16 million years old, much older. There's a big time gap right here at the base of these shells. These shells have been dated. They're about 110, 120,000 years ago. And that's the time of the last big interglacial. So what the USGS, United States Geological Survey, and mostly work that Dan Muse has done and his associates, is they dated this and then realized this was a wave cut bench from back during the last time sea level was higher due to this interglacial period, when in an interglacial, the polar ice caps get smaller, sea level rises. So what's happened here since that time, maybe as young as 80,000 years to about 120,000 years, sea level was high, and then we went into, as we got younger, into a glacial period. And so what happened is the alluvial fan came and migrated over top of these little marine lags that are here. These are just remnants of what was above the bench back at 110, 120,000 years ago. So above that's a bunch of alluvial, non-marine deposits. As sea level went down, this stuff advanced out, and sea level eventually out there got to be over 400 feet below its present level. Now, that happened at about 20,000 years ago, and since that time we've gone into the present interglacial. That's advanced up and created the modern sea cliff. So that's the story here. And if I walk out a little bit away from this deposit, I can show you the old wave cut bench that's associated with those shell deposits I just pointed out. Got to walk out here a little ways, so be patient. Incidentally, this is a beautiful beach. It's just, get a chance to come out here. It's a wonderful area. And let's see, get out here a little more. And you can see up the hill here, there's a little break and slope. You come up out of the modern day sea cliff, and then there's a sloping surface that slopes towards us. And there's a little break and slope. You got to climb up a little bit. And that's the old sea cliff at, this period around 120,000 to maybe as young as 80,000 years. So that's the last big interglacial sea cliff. You see the same thing on the other side of the channel over at Santa Rosa Island. And then if I was to walk out further here, let's see if I can get that. There's even a higher sea cliff, but we don't know the age of it. But it's got to at least be, a couple of 100,000 years old. So you're seeing more, again, of this 120 to 80,000 year old degraded sea cliff there. And again, this is the modern sea cliff. See if I can get out far enough without making this video too long and pick up the higher one. Oh boy, gotta walk all the way back here. We drove out today from Christie Ranch. We've been staying there. It's one of our little geo-hike adventures. And we'll came out here yesterday and we'll be going back tomorrow. So it's a pretty quick trip. I like to come out here for a little bit longer. Actually, ideal time is maybe 4 or 5 days out here, so you can see a lot more. Anyway, I'm going to climb up on the top of the little modern sea cliff here. And again, this stuff on the down below here, this is all the bedrock. It looks like andesite or basaltic andesite, and that's Santa Cruz Island volcanics there. So we're going to climb up the little sea cliff here. And you can see in the kind of medium ground distance, that's the 80 to 120,000 year old sea cliff. You know, maybe 110 to 120, but it's in that range somewhere. And then further back, you can see a sea cliff right there, right in there, a higher one. It's got to be like, you know, over 100 feet high, that one back there. We don't know the age of that. That's got to be older than, you know, 120. It's probably maybe like 200,000 or even back to the, you know, the prior interglacial, than the one prior or earlier than this 80 to 120,000 year old one we're talking about here. Anyway, let me scan around. Beautiful area. Again, we're on the west end of Santa Cruz Island, and for a December, having wonderful weather. That's it.